Now we are going to look briefly at the topic of resonance. So first of all, what do we mean by resonance? Well, the simple explanation is resonant when we cancel out all the reactance in the circuit. So the effect of the inductor and the capacitor are cancelled out and left just with resistance in our circuit. So resonance say that our impedance consists only of resistance. The value of impedance is minimum when XL is equal to XC, and this value is given by Z equal to ZR square plus XL minus XC square, and then the minimum impedance is equal to the R. So this phenomenon occurs at the resonant frequency, or we can say that the resonance is the phenomenon that occurs when the frequency of the applied voltage is equal to the frequency of RCL series circuit. At resonance, in the RCL series circuit, the impedance is minimum. Thus, the RMS current flows in the circuit is maximum, and it's given by I max equal to the VRMS over Z minimum and equal to the VRMS over R. To calculate the resonant frequency, so XL is equal to XC, and XL substitute equal to omega R, and XC is equal to 1 over omega C, and then we arrange this equation, omega square equal to LC, where the omega is equal to 2 pi f, and then we got the resonant frequency is equal to 1 over 2 pi third LC. The series resonance circuit is used for turning a radio receiver, and at a resonance IRMS and VRMS are in phase. In the AC circuit, power only dissipated or lost or used in a resistor. For the example, lamp, fan, or any electrical appliance. They use the power, then the power will loss. In pure resistor, the voltage and the current are in phase. Then we can get that instantaneous power is given by P equal to IV. What is the actually instantaneous power? Instantaneous power means that the power at a certain moment or time, or we can say that the power used at that time or at that moment. So we just substitute for the current I naught sine omega t, and the voltage in pure resistor is V naught sine omega t, and then we got the instantaneous power in pure resistor is P naught sine square omega t. Alright, and the graph shows of instantaneous power being absorbed by the resistor against time. And from this graph, we can get the average power, or we can call it the mean power that being absorbed by the resistor, and we get the equation. Okay, equation here, the average power is equal to half P naught or half I naught V naught. Right, from the graph here, you see, okay, the average power is equal to half P naught here. In pure capacitor, we know that the current leads the voltage by pi over 2 radian. Thus, we can calculate the instantaneous power, which is we use the same equation or formula, P equal to IV, and the current is I naught cos omega t because the current is leads the voltage, and V equal to V naught sine omega t, and then we get the instantaneous power is equal to the half P naught sine 2 omega t. Alright, so if you want to calculate the instantaneous power, let's say the question asks you calculate the instantaneous at t 5 seconds. Okay, so you just substitute the t, or the time is 5 seconds. From the graph of the power in the pure capacitor, we can see that the power being absorbed and power being returned to the supply is equal. What that mean? Okay, so for the power in pure capacitor, there are no power loss, okay, in a capacitor. Why? Because the energy in the capacitor can be stored as the electric field. For the example, a capacitor, you can charge the capacitor and charging, and the capacitor discharging and charging back. So the power being absorbed is equal to the power being returned to the supply. So the average power for the power in a pure capacitor is 0. In pure inductor, you can calculate the average power using the same equation, P equal to IV. But as we know, in the pure inductor, the voltage leads the current by pi over 2 radian. So the current is equal to I naught sine omega t, and the voltage is V naught cos omega t, leads by pi over 2 radians. So we get the instantaneous power in a pure inductor equal to half P naught sine 2 omega t. Okay, how about the average power in the pure inductor? In a pure inductor, there are no power dissipate or loss, because in pure inductor, the energy can be stored as magnetic field. You can calculate the energy by using U equal to half Li square, right, through the inductor, so that the average power in the pure inductor is equal to 0, because of the power being absorbed is equal to the power that returned to the supply. In an AC circuit in which there is a resistor, inductor, and a capacitor, so the average power is equal to the dissipated from the only of the resistor, right? So we have average power is equal to the IRMS, VRMS across the resistor. And then we know that the VRMS is equal to IRMS multiplied by R. So we get IRMS square R. From the phasor diagram, we can calculate the cos phi, the angle. The cos phi is equal to the VRMSR divided by VRMS by using Pythagoras theorem. So VRMS through the resistor is equal to the VRMS cos 5. So we get the average power here, okay, is equal to IRMS VRMS cos 5 and equal to the real power. Power factor can be calculated by using equation of cos 5 is equal to P real power divided by IRMS square multiplied by Z. Or you get the real power divided by apparent power. PA here is stand for the apparent power, right? So average real power, okay? Or you can use this equation also, which is a cos 5 is equal to the R divided by Z to calculate the power factor.